Hello guys, you're welcome to this lesson. In this lesson, we will be looking at quantum numbers. Quantum numbers. What are quantum numbers? Quantum numbers are integers or half integers that describe electron behavior in an atom. They are integers or half integers that describe electron behavior in an atom. They also describe atomic orbitals and labels the electrons that reside in them. They also describe atomic orbitals and label the electrons that reside in these orbitals. So when you say quantum numbers, they are integers or half integers used to describe electron behaviors in an atom. Is that okay? So these are integers or half integers. So integers or half integers used to describe the behavior of an electron in an atom. That is quantum number. It also describes atomic orbitals. It also describes atomic orbitals and labels the electrons that reside in them. What are these quantum numbers? In this lesson, we're looking at four main quantum numbers. One, we have what we call the principal quantum number. The principal quantum number. It is denoted by the variable small n. That is the principal quantum number. Two, we have the azimuthal. We have the azimuthal, or we also call it the angular momentum. Quantum number. It is denoted by the variable small l. Three, we have what we call the magnetic quantum number. So we have the magnetic quantum. The magnetic quantum number. It is denoted by ml. And then the last one, we have the spin quantum number. It is also denoted by ms. So these are the four main quantum numbers we will be going through in this lesson. So I said a quantum number, it is an integer or half integer that describes electron behavior in an atom. Integer or half integer that describes electron behavior in an atom. In addition to that, I also said it describes atomic orbitals. We were looking at atomic orbitals and the electrons that reside in these atomic orbitals. In this lesson, we're looking at four main quantum numbers. I said one, we have the principal quantum number. It is denoted by the variable small n. Two, we have the azimuthal or the angular momentum quantum number. It is denoted by the variable L. Three, we have the magnetic quantum number, which is denoted by M with a subscript here L. And then the last one, we have the spin quantum number. Is that okay? So now let's take each quantum number and break it down into details. Now let's take the first one, the principal quantum number. When you talk about the principal quantum number, what is it? The principal quantum number. It defines the main energy level of the orbital in which electron is occupying. It defines the main energy level of the orbital. So the principal quantum number defines the main energy level of the orbital in which electron is occupying. That's the principal quantum number. It defines the main energy level of the orbital in which electron is occupying. That is the principal quantum number. So the principal quantum number can have values ranging from positive 1, 2, 3, 4, 5, 6 above. Is that okay? That is the principal quantum number. The principal quantum number in the simplest form represents the shells. Is that okay? It represents the shells or the orbits. So when I take the structure of the atom, so in the modernized structure of the atom, we have the nucleus which contains the neutrons and then the protons. And then I have the shells. So a diagram drawn is not drawn to scale, so it is just a sketch. So what I have here is a shell or an energy level. This is another shell, this is another shell. So the principal quantum number in the simplest form indicates the shell. And which shells are we talking about here? That is the K shell, the L, the M, and so forth. Is that okay? So the principal quantum number defines the main energy level of the orbital in which electron is occupying. Or in the simplest form, it indicates the shell or the energy levels of the electrons. Is that okay? So the shells we're talking about here is the K shell, the L shell, the M, the N, the O, in that order. Is that okay? But we are saying that the principal quantum number is denoted by a variable small n. It means that each shell indicates n. Is that okay? But n has values, and its values ranges from 1, positive 1, to above. Is that okay? So it simply means that when we take our shell, which indicates the n, or the principal quantum number, we can say that the first shell, or the first energy level, should be n is equal to 1. That is principal quantum number 1, or the first energy level, or the first shell. And then we go on to the second one, that is the L shell. We can say that n is equal to 2. So here n is equal to 2. Is that okay? Then we can move on to the next one. That is the M shell. We can say that n here is equal to 3. In that order. Is that okay? In that order. So the principal quantum number simply talks about the shell. Is that okay? It simply talks about the shell. So we say it defines the main energy level of the orbitals in which electron is occupying. Or in the basic form, the principal quantum number represents the shell. And don't forget, it is denoted by small n. Small n here can have values. Its values can range from positive integers from 1, 2, 3 above. So if n is 1, we are saying that let the first shell or the K shell, that is the n here represents the principal quantum number. So its value can be 1, 2, 3, 4. So in a very simple form, we are saying that let the first shell be n is equal to 1. So it will follow in that order. The second will be n is equal to 2. The third will be n equals to 3. The fourth will be n is equal to 4. N is equal to 5 in that order. So the principal quantum number just talks about the energy level or the shells. Is that okay? So we already know that the first shell is called the K shell. That is the principal quantum number 1. The second shell is the L shell. That is principal quantum number 2. In that order. Is that okay? So that is the first quantum number. That's the first quantum number. We call it the principal quantum number. It defines the main energy level of the orbital in which electron is occupying. Now let's move on to the second one. But before we analyze the second one, the question is, from the basis of the modern structure of the atom, anytime we draw the atomic structure, as I have on the board here, I have my neutrons and protons making up the nucleus. Then we will locate electrons on the shells. We locate electrons on the shells. The question is, the electrons, are they actually located exactly on the shells? The answer is no. The electrons are found or located in what we call orbitals. What is an orbital? An orbital is a region of empty space within the energy level where there is a high probability of locating an electron. So the electrons are not just located directly or exactly on the shells as we know in the modern structure of the atom. They are actually located in what we call orbitals. And orbitals are a region of empty spaces within the energy level that there is a high probability of locating an electron. Is that okay? How do we understand these orbitals? That is why we introduce the next quantum number. And the next quantum number is the azimuthal or the angular momentum quantum number.